Hello and welcome to this video tutorial on using OpenMusic computer-assisted composition software. I'm Peter, I'm a master's student and a composer, and I'd encourage you, if you haven't yet checked out my previous video on some samples of projects that you can do using OpenMusic, I'd encourage you to take a look at that. In this video we're just going to be talking about some basics about working with the OpenMusic environment, how to navigate the various different windows and contextual menus and patches. So we'll just go ahead and dive in here and begin taking a look. So what I'll actually do, I'm going to close this and just reopen so we can see. So OpenMusic currently comes in a couple of different versions. OM 6.15 that you can see here, and then a beta version, which for a while has been designated OM 7. They've just recently changed that to being called OM Sharp because I think they want to indicate that there's been a pretty major change in the structure of the program. So I have OM 7 beta, and you can find it and download it for free online. I think at the moment it doesn't have quite all of the features that 6.15 has, so I've been using just the regular old 6.15 as kind of the standard version for now. But we'll go ahead and fire this up and take a look. So right at the beginning it's going to ask me if I want to create a new workspace, which is sort of like I think of it as like the sandbox that I'll be working in, or if I want to open one, or if I just want to open the one that I used previously. So for now I'm going to go ahead and open a previous workspace, but if this is your first time, go ahead and create a new one, and it will guide you through some menus about where you'd like to store the information for your workspace. It'll have you make a new folder to do that. So then what OpenMusic is doing right now, I've actually downloaded quite a few special libraries, and these are collections of software and patches that various OpenMusic users have produced throughout the years and have made available for other OM users. So a later video will discuss libraries, but for now that's just kind of what was going on down there. So this brings us to the workspace and the listener. So right now I've got a lot of different files and folders in my workspace, but yours is very likely to be blank, especially if this is the first time that you are using the software. And so what this area is just a way of collecting and organizing the various patches that you produce, as well as other objects. So down the line you may use an object called a maquette, which is a way of kind of sequencing audio events or notation objects in time, kind of as a way of coming up with a sketch of a composition. But the basic idea is that the workspace is just a single place to contain all of the patches and folders and objects that you'll be producing. Kind of in front of my workspace here, I also have the OM listener. And the listener is just the place where OpenMusic is able to kind of talk back to you as the user. So as it was loading, it was telling me what it was doing. Later, when we get into working with patches, the listener will become a really important place to see what's going on with the patch and to see what kind of results the patch is producing. So I just always have the two of these up because I use them so frequently. And yeah, they're just really useful. So to begin with, let's go ahead and go up to our file menu, and we'll make a new patch. And of course you can use the Command 1 keyboard shortcut. And here in the here in the environment, it has added this new patch, just named patch by default. So we can rename this whatever we'd like, and that's just done by double-clicking on the text here. Now, if we'd like to open this patch, we can double-click right on this icon of a kind of patchwork plaid fabric design, and here we have a beautiful brand new patch. So this is where the majority of your work in OpenMusic will take place, and it really is just kind of a little sandbox for you to work with various musical objects, mathematical objects, and if you've seen some of the last videos, or I should say just the last video, you can see that there are a lot of different ways that you can structure a patch like this. So to begin with, maybe I'll just go through some of the really commonly used objects in these patches, and then we can take it from there. So at least for me, one of the ones that I use most frequently would be a chord sequence object, and it's abbreviated as Chord Seq with a Q. And a chord sequence is really just exactly what it sounds like. It's used for constructing sequences of chords. And it really, a chord sequence has some very specific properties that we can look at in a later video, or you can find in the OpenMusic documentation. So if you are interested in learning more about the chord sequence object and what makes it distinct from other type of music notation objects in OpenMusic, a quick way to do that would be to click on this chord sequence object and then hit your D key on your keyboard, which will conveniently open up some documentation that'll give you some information. Also, if you open your help menu and go here to documentation, if you open the help menu and go to online user manual, that will conveniently open up the official OpenMusic documentation. You can do a quick search for chord sequence, and as soon as that loads, you can find a whole explanation of the nature of the chord sequence object, how it's used. If you click on presentation, it will show you how it kind of fits in with the system of music notation objects in OpenMusic. So it's really handy to know how to quickly get to documentation and look through that. But for now, let's keep on plugging along. So just to review, making a chord sequence object, you can double click in the patch, type in chord seq, and then you've got your chord sequence object. And that can easily be dragged around, resized, all sorts of things. So let's just start with this and work through a couple of useful things. One thing that can be really helpful to know right off the bat is that you can actually preview the contents of this chord sequence. So if I click and select it and then hit M, as in monkey, on my keyboard, all of a sudden I get a preview of this chord sequence. But by a similar token, if you type N, N as in narwhal, you get the name of this chord sequence object, which by default is named chord sequence. Now if you want to rename this, you can right-click and then bump down to Get Info on that contextual menu, which should pop up with there we go, which will pop up with this field where you can rename it. So how about that? And again, this can actually be really useful if you are categorizing large collections of chords, or or melodies or any sort of objects and need a way of keeping track of what's going on. All right, so the last thing that I would say about the chord sequence object is it, like almost every OpenMusic object, has the option of being in a locked or an unlocked state. So if I click on this chord sequence and then hit B, you'll see that an X, a blue X, appears in the top left-hand corner of this object, showing that the object is locked. And that just means that, that for now, OpenMusic will not let the data that this object contains to be changed. So if I want to unlock it, I can go ahead and hit B again, and now, now this is kind of open to being changed. So locking and unlocking patches actually is a really critical part of working with OpenMusic, and we'll see that kind of down the line. But it's very helpful to know how that works. So now that we've got this this chord sequence box, one of the things that I want to quick mention is the structure of OpenMusic and the way that this software is intended to be used. So OpenMusic is built off of a computer language called Lisp, which was developed fairly early on as far as computer languages go. And Lisp is a language that primarily uses lists of objects and is really structured around lists. So if you know a little bit about set theory, and by which I mean mathematical set theory as opposed to like pitch class set theory, if you know a little bit about set theory, it can be really helpful in understanding how lists work, how they function. So I'm just going to make a sample list. I'm going to double click, and I'm going to start with a left parenthesis, and I'm going to type a couple of objects into my list. Alrighty, so I've got a lovely little list, and this list contains 4 objects. 4 objects in this list. And maybe right off the bat, I want to access one of the objects in this list that I've created. Well, I can do that a number of ways. I can just type in, for example, second, and then if I double click here on this little kind of nodule and double click drag over here, I'll connect those with a patch cord. So this patch cord connects this outlet, which is represented by this kind of blue periwinkle node, this outlet here connected to this inlet. So I've got this all connected up, and maybe I just want to check that this function that I've created, second, will actually access the second object in this list. So what I can do is click on second till it's highlighted, and then I'm going to type the V key on my keyboard, V as in vulture, for evaluate. By typing the V key, it evaluates this function. And you'll see when I do that over here in the listener is where I can see the results of this evaluation. And sure enough, it's saying the second object in this list is the word is. So I can do the same thing. I can type in fourth, connect that outlet to this inlet, highlight that, evaluate, and we get list, which is just great. That's what we would expect. So now I'll try 10th. And of course I don't have 10 objects in this list. So OpenMusic tells me that. It says nil, which is its way of saying there isn't a 10th object in this list, so there's nothing that I can return back to you as a result. And so nil is actually a really important part of the way that OpenMusic is programmed. It'll be an important concept as we go on. Another thing that I can do is I can make a function called nth, as in I'd like the nth element of this list. So I'm going to connect it to this inlet called original list. And then what I'm going to do is I'm going to hover over this left inlet, and I'm going to hold down the Shift key and click, which will very conveniently create a box already connected to that inlet with a patch cord. So then I can type in a number and get a result. So one thing I'll demonstrate here is earlier I used the object first, and it did exactly what we would expect. It returned the result as this, where this is the first object in the list. Notice though that if I use nth and type in a 1, I'm actually going to get is back. I get is rather than this. And that's because what this is doing is actually taking the index of the list. The index of the list. So kind of colloquially, using first, second, third, all the way up through 10th, those functions do what we would expect them to do kind of in normal English. But nth again is going to work based on indexes. So what I mean by that is, actually let's do it this way. We can actually kind of demonstrate how this works. So if my list is the words, this is my list, the computer will assign numbers to each of these elements of the list as indexes. So the index of my is 2. The index of this is 0. The index of list is 3, and so on. And it's important to remember that OpenMusic will begin counting at 0. So the first object of your list will always have the index 0. And that's why we got that strange result when we typed in a 1. Now knowing what we know, we can expect when we type in a 0 that we'll get this back. And sure enough, we do. So that's just one thing to be aware of with lists. The index will always begin counting at 0 rather than 1. Great, so this is all well and good. We've got some lists and we know a little bit about how they work. But why do we care about this? What's really the practical use of lists? Well, lists don't just work for strings of letters like we just used to write those words. What we're really interested in much of the time is using lists to represent rhythms, pitches, maybe the assignment of various MIDI channels. So we'll just do a little demonstration with some numbers here to see what kind of results we get. So I've typed in some numbers, and I'm going to connect this to this second inlet of the chord sequence, which is made to receive MIDI pitch information. So I've connected that up. I'm going to type V for evaluate, and sure enough, we start getting some interesting pitch information. So let's open this up here in our chord sequence viewer. And let's just spend a little bit of time looking at this window. So one of the first things that you'll want to do probably, especially with pitch information lower than middle C, will be to change the staff that you use. So if you'd like to use a grand staff, you can select GF, where G represents treble clef and F represents bass clef or F clef. If you have really wide-ranging pitch material over several octaves, you can do this double G, double F here. And what that will do is this second treble clef is now an octave above this one. And this bass clef is now an octave below this one as well. So that can be really helpful for working with very large chord structures or really wide-ranging melodic patterns. But for now, we'll just stick to the grand staff. Also, if you're going to be doing some work in this preview editor, preview window, it can be helpful to kind of change the size a little bit so you can read more easily. You can also change some of the spacing by using this zoom function. And that's actually most useful. Here, let me pull up a different patch. Where did that go? There we go. That's actually going to be most useful when working maybe with large collections of chords or with melodic material. Let me find the right. Here we go. Yeah, this is the one. So for example, this was a case where I wanted to specifically have these chords spaced out so that these chords began right on that system. So if I change the spacing, that kind of ruins the organization that I wanted. So knowing how to use that zoom can be good. And at 103, there we go. So what I'm doing here is I'm just clicking on this box, holding and dragging left and right. Or maybe kind of diagonal is better. Yeah, that's a little better. And that gets me right where I want. Now, one thing that's different in this chord sequence editor is we're in page mode, where we can see this spread out as a couple of pages. And again, you can actually, Command P and send this to your printer, get it out in a hard copy. But to get that to happen, you're going to have to right-click and then in mode change the mode here. So we have different modes that serve different purposes. This is closer to what we saw in the other chord sequence editor. But page mode was helpful for getting this printed out and actually working with it as I was composing this piece. Okay, maybe the last thing that can be helpful is these values here. So right now this is selected to show MIDI Sense. Again, where a cent is a unit of measurement of frequency. So 100 cents would correspond to a half step or a semitone. So this is showing MIDI pitch content in terms of cents. So if you're familiar with MIDI, you know that different MIDI pitches are assigned different numbers. And typically we think of them in terms of just two-digit numbers. So like middle C would be 60, C sharp would be 61, D sharp would be 62. But you'll notice here in this window as I adjust up and down that it shows it as a multiple of, what would that be, 100. And the reason that it does that is actually really helpful. So for example, in OpenMusic you can work with microtones, and you can work with them by using MIDI Sense to the degree of resolution of 100th of a semitone, which is really awesome. And you can't do that if it's just 60, 61, 62. So that's the reasoning behind having the 6,000, 6,100, 6,200, 6,300. So you could have something like 6,350, which would be halfway between that D sharp and the E right above it. There are other things here that you can explore. Again, if you're curious, you can look at the documentation, and that'll have some more details about how that works. So again, these lists are really useful for pitch material. They're also very useful for rhythmic material. So I'm going to add a new object here. This is a voice object. And you'll notice on the surface it looks maybe similar to the chord sequence object. The chord sequence object doesn't really have the restrictions that are placed on the voice object, and they kind of serve two different purposes, right? So the chord sequence object is sort of like maybe a piece of music manuscript paper without any bar lines, or you can really just kind of sketch whatever you need to. There's no tempo really associated with it. If you open it up, you'll notice that it measures time in milliseconds. So you can move around objects kind of on a millisecond basis if you want. So it's very, very free, very open-ended. This voice object, on the other hand, has a time signature, has a tempo, and it's meant to be used to represent a polyphonic voice. So what I'm going to do here is I'm going to show a way that we can use a couple of lists to create a polyphonic voice here. So let's just do this. We'll make some little changes. Okay, so I'm going to connect this list over here and just take a look at these inlets. So we're going to skip this one for now, and we're going to skip this one for now as well. But we're going to dump this into this inlet called chords. And then what we're going to do is we're going to make another tree. And what I'm going to do here, maybe to demonstrate, will just be something like this. So we've got a list of 4 ones. Then I'm going to add another object by typing in OM and then a slash. And this is a division object. So I'm going to connect that inlet. I'm going to shift click on this other inlet and type in an 8. And so let's just take a look down here in the listener. I'm going to click on this division object and evaluate, and we get 4/8 in our list. Then I'm going to add one more object. I'm going to type in mk tree, and this is the make tree object. So as I've mentioned, so many different types of musical data in OpenMusic are represented by lists. And sometimes lists will colloquially be referred to as trees because they have kind of this like branching structure at times. So that's the reasoning behind this use of the word tree here. So what this object is going to do is it's going to format a rhythm that this voice object can successfully read. And so what I've done here is I've given it some rhythms, and I've also told it, and it picks this by default, that the time signature will be 4/4. So that's what that list represents, a 4/4 time signature. So I'm going to connect this outlet down here to the tree inlet, select the voice type evaluate, and here we go. We've got some rhythmic material going on. So that's really nifty. That's really cool to see. Let's make this just a little bit more interesting. Let's try something like 3/8 and evaluate again. And here we go. We see, sure enough, we've got a 3/8 time signature, and our rhythm has been maintained, the 4/8 notes in a row. If we want things to be a little bit more interesting, we could do something like this. And here we see we've got an 1/8 note and then a quarter and 2/8. Even if I do something like this, OpenMusic will successfully interpret that and tie over the bar line. So I maintain the pattern 1/8, 3/8, 1/8, 1/8. So this is really powerful. You know, you can conceive of rhythmic patterns in OpenMusic in terms of proportions, which is very helpful. And by using a make tree object and designating a time signature, OpenMusic will figure out how to interpret that. And it can do that pretty complexly too. So let's add some more objects to this list, just kind of at random. Oops. And you'll notice it's not changing anything yet because I haven't given it an equal amount of rhythm information. So let's go up here and add a little bit more. We get some more material here in terms of pitches. And one thing I can do now too is also maybe I decide I want to use some mixed meter in this example. So what I can do, oops, I made a mistake. What I can do is add more meter representations in this list. And notice I have to use 2 parentheses at the end because now I've made a list of lists. So the outermost list has 3 objects, and each of these sublist objects has 2 objects, each one representing a time signature. And now as I evaluate, all of a sudden I've got some really cool stuff going on with the mixed meter. Likewise, I can do a similar process. Let me see if I remember how this works. Yeah, let's do. Oops, that's not it either. I may have to go take another look at that later. Suffice it to say, you can actually divvy up the proportions inside this rhythm tree. I'll have to review. Let me take a look actually at a different patch where this happens. Let's see. Okay, maybe I'll have to go back and do a little bit of research to find that out. But yeah, you can divvy up those proportions within that list and work with like proportions of that 3/8 segment as well, which can be really fun. You can do a lot of pretty sophisticated rhythmic patterns using voices. So those are just some examples of ways that you can use lists as representations of musical objects and data. Lists are one of the most powerful features of OpenMusic that make it so easy to do so many complex types of operations in the software. So thanks so much for watching this video. Hope that this was informative and useful. And if you learned something or if you have any questions, feel free to leave a comment. I'd be happy to take a look at those or try and recommend some resources. And I hope to see you again for the next video.